Hi there. Today we're going to be looking at working with files in Java and using the Netbeans IDE. If you start Netbeans, you're probably going to be greeted with a screen that looks a little bit like this. There are the recent projects you've been working on, and otherwise the last project that you had open will be open on the display in front of you. I'm going to start by creating a new project, File, New Project. And you'll see we have several package managers available. There's Maven, Gradle, and Ant. Ant is the oldest of these and the one probably most commonly used in your textbooks. Netbeans is built around Maven. That's sort of its native package manager. So I'm going to stick with that for the moment. So Java with Maven, and we're going to choose Java application. Next. We give it a name here. I'm going to call this file e.g. file example, and the rest can stay more or less the way it is. We're just going to stick with the defaults. And there it is. So Netbeans gives us a basic Hello World application, and you'll see that our main class is file e.g. So obviously we are using the source file, file eg.java, and we're not going to use the code it's given us. It's just given us system out println, so we can get rid of that. Right. We're going to be working with a file, so I'm going to create a file object. There we go, file, and I'll call this file, a very inventive name, new file, and inside the parameters for the constructor, we'll put the file path. Now it's underlined file because this does not yet exist in the imports. Alt-Enter, and it gives me some choices. The first one is add the import for file.io. So Netbeans has added this line, and it also means I'm now being prompted, the little text down there is just a prompt to say we need a file path. I'm going to call this file biodata.csv because it's going to contain comma separated values. Right now the file does not exist. We're going to have to create that file, and we'll do it shortly, but I want to illustrate a few errors first. You'll see that it's prompting me for the path name, but I've just entered a single file name. The full path would include the folders that it'll be placed in, but I'm going to create this file in the project root, so it'll be able to find it without needing the full path. Right, let's see how we go about reading from files. To read from this file, I'm going to use a scanner object. There, I'm creating the scanner. The scanner you may already have used when you're dealing with console input, and that would have looked something like this. System.in refers to my system console, and as far as this is concerned, that is also a type of file. If we go back in history, many different systems used the metaphor of a file for processing. So you may have seen the print screen key on your keyboard. That was originally to print, literally, what is on the screen to the file that was the printer. And the process was very much the same as saving. At the moment, the scanner is not included in the imports, which is why it's underlined. So Alt-Enter, Alt-Enter. There we go. And we're going to add the import for the scanner. Again, it's added a little line for the import, and we can carry on. Now, working with system.in, I would have used a line that looked something like this for input. String, let's just call this line, equals, and we're going to use a scanner, scanner.nextLine. That would give me the next line, and to demonstrate, we'll print it out. So we have this shortcut in Netbeans, SOUT tab, and that does system out print line, and I can say the line is line. There we go. So I don't have any prompts at the moment, so it's just sitting there and waiting for input, and I can type something, and there's the output. What's up? Okay, but we're not interested in getting input from the console at the moment. We're trying to read in things from the file. So let's see how that would change. Remember I said that is a file, as far as this is concerned, which means I can replace system.in with a reference to my file. There we go, file. And it's given me an error. The error isn't because I've added that file variable to the parameter list. If we hover over this, you'll see a little hint. It's complaining about this file not found exception. When we're working with files, if the file doesn't exist, Java is going to throw an exception, and the newer versions of Java insist that we handle that exception. So let's try that Alt-Enter trick again. Alt-Enter, you'll see, gives me two potential answers. I can add the throws clause to the method itself. So main will add a throws clause. Let's just do that so you can see what happens. Boom, there we go. And what's happened? It's added this line, throws file not found exception. That's going to defer this error to be managed later. If I were to run this program now, it will work, but it'll throw a major exception to say, yo, this has not worked. And here is our exception. Exception in thread main. This is really not very user-friendly. You can imagine your poor user having a hernia as soon as they see all of that. So rather than deferring this, we're going to try and manage that exception. So we delete it, our red line is back, and this is the alternative. When we're trying to manage exceptions, we can manage it explicitly by wrapping this in a try and catch. So here is what Netbeans has done for me. You can see first it's split the scanner into a declaration and then an initialization. That doesn't affect the error at all. What it has done though is it's added try and catch. Try means it's going to attempt to read from the file, and if it fails, it will throw an exception which is then caught by the exception class, file not found exception in this particular instance, and the particular instance of that we've created is named X. It's also added this for me, a logger, and the appropriate imports for that logger as well. You'll also notice we've got the import for the file not found exception. The logger is a class that logs to the standard error device, which is usually a file, and it manages the record keeping of all our errors, which is a really nice little addition. It's still not very user-friendly. If I were to run this now, we'd still get a bit of a display of the error. The other thing it's done, you'll notice it's caused a bit of an error. Here, this line refers to the scanner class. There it is, my instance of scanner, but scanner right now is initialized inside my try, so it may not be initialized. If there's an error and we reach this line, then the line that refers to the scanner over here won't have a value. The scanner won't function. So that's why it's giving me this warning over here to say variable scanner might not have been initialized. So just for the sake of getting rid of that message, I'm moving this into my try block. Right, let's run this and see what the difference is. And we run, and it's going to give me build success. And there is my updated error message. So it gives a class for the error. It's not quite as scary as the previous one, but there's still a lot of stuff. And this isn't really kind to your users either. So the benefit of the try catch block is I can use the logger to log to standard error, and I can also, if I want, I'm going to take this out, display a slightly more friendly message, which would be something that the user would see and hopefully appreciate. System.out.println, and just say something along the lines, file could not be found. Run it now, And here is our error. File could not be found. That's much less intimidating for someone who's working with a program. At least now they know what's going on. They don't have to interpret any codes. So we've handled the error, but we don't yet have the file. Our exception is working. We have to create that file. To create that file in Netbeans, I'm going to right-click on the project itself, go new, and this is going to be another, and we want a text file. We want just a ordinary file, empty file. There we go. And we're going to call this biodata.csv because it's going to contain that information, and finish. Right, so I should now have biodata.csv, which will be in the root of this. Let me just type Joe Soap, and we'll give him some other ID number, 512215072083083, some random ID number. Give him a date of birth. I see I made him 1975, December 21st. There we go. And we can save this. Now, if I were to try and read this file, the file should exist, and I shouldn't get an error. What I should get is, there we have the line from the file. So simple. The same thing that we had for system.in. I haven't changed anything except in changing my input source from system.in to the file instance that I created, and wrapped it in a try and catch block to manage the exception. Well, this is a comma-separated value file. So how are we going to get the values out of that? Well, we can use a scanner, just like this one, to do exactly the same thing. I've read that line from the file. Let's create a second scanner. A scanner is a string parser. Its job is to split strings into tokens, and by default it'll split it on spaces. If I have a string that looks like this, this is a string. The default for the parser, don't mind the error, this is just an illustration of strings. The parser will say, oh, there's a space, and it'll split that word into the first token, and then it'll take the next one after the space. There we are. And the next one after the space. So I'm going to end up with several tokens like this. This is a string, and I can refer to them every time. We can use that with the line as well. So I'm going to call this one line scanner equals new scanner. And I'm going to connect it to that line that I've just read. Scanners don't just work with files, they can also work with text strings. Just while we're on the topic, because it reads the whole file, that means it places limitations on how big a file we can read, because it has to be contained inside memory. If I was going to try and process very large files, I'd have to use something different, maybe a buffered reader or something like that, which can read the file in chunks. All right, I've got my line scanner. I've connected it to line. I need to change that delimiter. We're using a comma-separated value files. So I have to adjust the delimiter for this scanner to use commas, which we can do using the useDelimiter method. Line scanner dot use, and there we are, useDelimiter, and the pattern we're going to use is just a comma. These patterns, well, you'll notice the prompt for a pattern. They can be multi-character things. So, for example, the traditional Unix password file used 2 colons to separate the values. Those have now been replaced. They're much more secure than just values separated by colons. It could also be a regular expression, which is much fancier processing and beyond the scope of this little tutorial. Right, so I'm using a comma. Let's create some fields. String, let's call this client name, And we're going to read that token. Remember, this will have split on the very first token now of that line. So the token is there. We're going to read that. So line scanner dot next. We're getting the first token. And we're going to do exactly the same for the ID number. Client ID equals line scanner. I see I missed out a N. There we go. Spelling is always important with this thing. String. And we're going to read the date of birth in as a string. Let's see what we got. We're not printing out the line anymore, or we can print out the line. So name. And let's add the ID. And we want the date of birth. Typos are us. Okay, let's see what we get. And here we have our output. So there is the full line. And after splitting it up, we've got the name, the client ID, and the date of birth. All right, we're almost done. This file has only one line. How would we manage this if the file had several lines? This is Joe's sister Jane. Let's go with some slightly different number. 1979, and I said March, and 21. Yeah, what do you know, also the 21st. All right, so we now have two names. Save that. As we run this, it's still only going to read the first line. We are only processing the first line. There are two lines in the file. So we need a way of wrapping this process, reading a line from the file and doing the processing that we're doing for every line in the file. Unfortunately, you can't really predict how long a file is going to be. The files could be one line, as that first line was, or thousands of lines. So we need to be able to continue until the line ends. While loops are perfect for this. So I've created my scanner and I'm reading the first line from the file. Before that, we can create a while loop that says while the scanner has next, while there are still more tokens left in the file, of course we do have to spell that correctly, we can keep on doing this stuff. And this loop is going to end there. We want to indent that. Indentation is a really useful thing just to make sure you can see where blocks begin and end. And I would really encourage you to do that. It is part and parcel of good programming technique. Okay, all we've done is we've added the while loop. It's going to continue as long as there are lines in the file. Let's see what happens. And there we are. You'll notice we've got Joe Soap, and we've got Jane Soap, and we've got the individual data fields for each one of them. And that's it. Managing text files in Java and using a scanner to split the lines. I hope you find that useful, and I'll see you again next time.